Hi, this is Julie Hester, and in this video I want to talk about some things you need to know when working with numbers in the C++ language, and that's type conversion and integer division. And this is sort of like working with apples and oranges. We have two major number types, integers and floating point numbers, and sometimes we need to convert one type of number to another, or we may not get the results that we want. So let's start with type conversion. And this just means that we're going to temporarily change a value's data type. And usually we're working with ints and doubles, so we're converting between one or the other. And sometimes we see this as an implicit conversion. We may not even realize it's going on. But the computer or compiler is going to automatically change the data type of one value to match the data type of another. And so what do I mean? Well, if I have a mathematical expression and I'm adding two numbers, subtracting the number from another, or something like that, I need both of the numbers to be the same data type. And so I need them to either both be floating point numbers or both be integers. And so this is going to happen implicitly for me. It'll be automatic, and then the value will be computed. The original data type isn't modified, and then the program will continue. Sometimes I may, as the programmer, want to tell the computer that I need the data type to temporarily change. And this would be explicit type conversion, or also called typecasting. And we'll see how we might use typecasting with integer division in just a moment. But first, I want to talk about implicit type conversions. So what's really going on here? Well, as I just said, in a mathematical operation, we need the two values to be the same data type. And a lot of times what we're going to be doing is promoting an integer to a double. And in this example here, I'm adding 5 to 6.2. I need both of these numbers to be the same data type, and I want to do this in a way where I'm going to lose the least amount of data. If I made both of them an integer, then I would have 5 plus 6, and the result would be 11, and we would lose the 0.2. So that's really not a good way to go. Instead, the compiler is going to promote the 5 to a double, and I'll be adding 5.0 plus 6.2 for a total of 11.2. It's the kind of thing you automatically do in your head, but for the computer, it's not totally automatic. Code has to be built into the compiler to handle this. Other situation where we'll see implicit type conversions is with assignment. And when we are assigning a value to a variable, whatever the value on the right-hand side of the equation is, that has to become the same data type as the left-hand side. Well, this makes more sense with an example. And let's say I created an integer variable called pi, and I want to assign 3.14 to it. Well, 3.14 is a double, but pi is an integer in this case. We can't make pi's data type change. So we're going to have to take the right-hand side value, the 3.14, and demote it to become an integer. When we demote the value, we're going to lose the fraction, we'll truncate the value, and now pi will be equivalent to 3. Well, this is probably something that we might do by mistake. Probably isn't something we intended to do. And to help us out, a lot of compilers will give you a warning when it sees something like this. In Visual Studio, you'll see a message like conversion from double to int, possible loss of data. Now this is a warning because the compiler can do this and the program can run and execute. But the warning is saying you might want to pay attention to this because this might not be what you want. And that's why whenever you get compiler warnings, you should look at the warnings to see if maybe they're indicating a problem that you need to fix. In this case, there's no reason why I would ever want to assign 3.14 to an integer. And so probably what's happened here is I made a mistake and I used the wrong data type. If I look at this warning, I'll see that. I know that I need to change that int to a double or whatever it is that applies to the situation. I also could have something like this where the right-hand side is 5 times 12. 5 and 12 are both integers, so I'm going to do integer multiplication. The product will be an integer, but I'm assigning it to a double. In this case, the integer is going to be promoted up to a double, and the value 5 times 12, or 60, will be assigned to the variable named 60. I'm not assigning a double to it, but that's not a problem. It could be a variable that I'm going to use later on in the program in places where I will be assigning fractional values. So it may be correct that I really do want this to be a double. Sometimes situations like this will be flagged, or you may see it flagged either in your IDE with an underline or something, or you could see a warning for it. But this one is going to be less problematic than the first case where we're demoting the double to an integer. So those are the two types of implicit type conversions where we're either changing a data type in order to perform an operation, or we're changing a data type because we're assigning it to a variable with a different data type. And this is something we need to keep in mind when we're working with division. And division is a special case. And we have two kinds of division, like two kinds of any other operation. We have the floating point division, where either of both numbers are going to be a floating point value. We'll promote an integer if it's not already a floating point. And then the value of that division will be a floating point value. It's not something that we really think about. It's more automatic. But here's an example of that. I have two numbers, x and y. They're stored as doubles, even though they happen to have integer values. If I were to divide 4 by 5, the value of 4 divided by 5 is 0.8. I'm dividing a double by a double, so the result will be a double, and I'll get exactly what I was hoping for. The other kind of division is where I can have problems, and that's with integer division. In this case, both of the numbers are integers. And if I add two integers, or I multiply two integers, I'm not going to have a problem. Because anytime I'm using two integers in an operation, the result is going to be an integer. And with most operations, that's just fine. However, with integer division, when we divide numbers, we aren't necessarily going to get an integer as the result. But because I have to store it as an integer, I'm going to discard the fraction and truncate the number. And this may not be what I want. So in this example, I have the same numbers, but this time I'm storing them as integers, x and y. And when I divide 4 by 5, now I'm dividing two integers. 4 divided by 5, well, mathematically it's 0.8, but I'm working with an integer and I'm going to truncate the fraction, and now 4 divided by 5 is going to be equivalent to 0. And this is one of probably the most common errors in programming with C++, and sometimes these errors are hard to find because you just may not notice that you've done this. Let's look at a couple of examples of things that we'll see with integer division. The first one is more obvious. Here I have a triangle with an area of 0. So I'm going to work with a triangle where it has a length of 10 and a width of 5. And if I were to do a calculation of that, the area of a triangle is half times length times width. So 10 times 5 is 50. Divide by 2, I should get an area of 25. But when I wrote the expression in C++, I wrote a 1 divided by 2. 1 and 2 are both integers. And what's going to happen is 1 divided by 2 happens to be 0.5, but those are both integers. I have to have the result as an integer. I'm going to truncate the 0.5, and now 1 divided by 2 is going to become 0. I'll multiply 0 times whatever length and width I have. And this triangle, or any other triangle with this formula, will have an area of 0. That's a kind of error where if I see my triangle has an area of 0, that's probably going to stand out to me as that doesn't look quite right. But sometimes these errors are harder to find, and I'll show you one of those. Let's look at calculating the volume of a sphere. Now this is a more complicated formula, and when I look at the result of it, it's going to appear like it may be correct, but I'm actually going to get the wrong value. If you don't remember the volume of a sphere, it's 4/3 pi r cubed. So let's set up our variables. I have a named constant of pi equivalent to 3.14. And then I have a double for my volume and my radius. All of that looks great. My radius is 5.1. I want to know the volume of that sphere. So I'm going to build the formula, and it's 4/3, or 4 divided by 3, times pi times radius cubed. Here I'm using the PAL function to cube radius. I'll do the calculation, and then I'm going to see that the volume of the sphere is 416.524 units. Now this is not a calculation that I'm just going to easily do in my head, so I could look at that result and think it's fine. But it's not the correct answer. The volume should be 555.366. That's the correct answer. So what's going on here? Well, again, we're working with integer division when we divide these two constants, 4 and 3. 4 divided by 3 mathematically is 1.33, but with integer division, 4 divided by 3 is going to truncate that fraction. It's going to become 1, and now we're multiplying the other values by a smaller number than we should be. So in this case, this might be a harder problem to discover. And what can we do about this? Because we don't want to have this problem. Well, I'm going to talk about 3 different solutions. First solution I can do is if I'm working with integer literals, I can change one of them to a floating point literal just by adding a 0.0 to the number. So I'm going to go back to the triangle problem, and here I have 1/2 length width, but this time I'm going to change the 1 to a double by making it 1.0. Now when I do my division, I'm dividing a double by an integer. The integer gets promoted to a double, and I have floating point division. That will be equivalent to 0.5. I'll multiply that by the 10 and the 5, and now my triangle has an area of 25. So that's one thing I can do. Now that's not always a possible solution because I may not have a situation where I'm working with integer constants like in this expression. Sometimes I'm only working with variables, and what I could do is wherever I have an integer variable, maybe I could use a double. This is not always going to be practical or possible, but it will change the result. So here, where I had the 4 divided by the 5, if I can made the 4 and the 5 doubles instead of integers, I will see the 0.8, and the 0.8 will be displayed. But again, I don't always have the flexibility to change my data type for something that might be part of a division problem. And so if I don't have a constant that I can modify, or I can't modify my data type, then I have to use the third option. And this third option is going to be typecasting. And this is where I am going to explicitly change a variable's data type while my program's running by using typecasting. So originally we had talked about implicit type conversion. This is the case of the explicit type conversion, where I'm going to deliberately tell the compiler, hey, by the way, I want you to make this number act like it's a double while you do this calculation. It's a temporary conversion. And this is how we do that. We're going to use this complicated looking structure here called static cast. So we'll write it like this: static underscore cast. Then I'm going to use angle brackets around the data type that we want our variable to become. So if we want to make an integer a double, we'll put a double in there. And then finally, in parentheses, I'm going to put the name of my variable that I want to convert. And this is something I might use in a problem where I'm averaging numbers. So let's say I added up 5 numbers and I came up with a total of 14. I want to calculate the average. Now the sum and the count were both integers because I was adding integer values, and I'm not going to have a fractional count. So it made sense that I had 2 integers. And when I go to calculate average, I'm going to divide the sum by the count, but they're both integers. I want to store it as a double because I know an average can be a fraction, but I'm not going to get a fraction if I write it like this. And incidentally, I just want to remind you that in this problem, I know what the values are, 14 and 5. We don't want to type the numbers in the formula directly. We want to use our variables. But let's take a closer look at this. So when I do this calculation, what I'm going to find is that 14 divided by 5 is 2. Because the actual result is 2.8, I'm going to truncate the 0.8 when I do the division, and now I'm going to say the average of those values is 2. Well, 14 divided by 5 is actually almost 3. And so when you're talking about 2 versus 3, I really want it to look more like a 3 than a 2. So this is not a very good answer to this problem. I may not have the ability to change the variable data types. So here I'm going to use static casting. I am going to replace where I had the word sum, or the variable sum, with this construct here, static cast. I want it to become a double, and sum is the variable that I want to temporarily typecast. Now, if I put that in place of where I had sum in this expression, and I have the static cast divided by the integer count, now the integer count will be promoted to a double. I'll do floating point division, a double divided by a double, and then I'm going to store it in a double. Everything will be great, and now instead of getting a result of 2, I get the correct answer of 2.8. So this is a way that's always going to work for you if you use static cast. It just looks a little long and ugly if you haven't used it before. That we can use static cast to temporarily change any variable's data type while we're doing a calculation. So for integer division, the big problem here is we're dividing 2 integers. We'll always get an integer as the result, but that may not be the accurate answer. We may need this to become a floating point number, and we have to find a way to convert one or both of the values to a floating point in order to get floating point division.